Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for doing this for us. Now let's look at our activity for today. We would continue with our lesson on sets and set operations. We will be looking at part 4 of this topic today. And in this part, we'll be learning to describe and identify various regions of the Venn diagram. Here we'll focus mainly on two intersecting sets. To start, let's first look at what the Venn diagram is. Now, we've already looked at what sets are. And you need to also note that sets can be represented using diagrams. These diagrams that are used to represent sets are what we call Venn diagrams. We can use various shapes to represent sets. For example, we can use triangles, rectangles, squares, circles, ovals, many other shapes to represent sets. So we can say that Venn diagrams are pictorial representation of sets. Let's take the set A. This set A contains the elements or members 1, 2, and 3. We can represent set A pictorially using the following Venn diagram. Now let's look at the set X. It can be represented pictorially using the following Venn diagram: a rectangle. Finally, let's look at set M. We will use an oval shaped Venn diagram to represent this set. I need us to note the following under Venn diagrams. First, let's note that universal sets are usually represented by rectangles. Secondly, other sets are usually represented by circles or oval shape. We will start by looking at the Venn diagram with two intersecting sets. This is our universal set, represented by a rectangle. We have our set A, represented by a circle, and it is also a subset to the universal set. So the set A has been drawn inside the universal set. We have another set, set B, which is also a subset to the universal set. So it has also been drawn inside the universal set. At this point, we would intersect set A and set B. Now, set A and set B have intersected. Let's now identify some regions of a Venn diagram with two intersecting sets. We will start by shading a region showing set A. This is the region showing set A. Let's look at the next example. Here we'll be shading the region A complement. First, let's show our universal set of two intersecting sets. Let's note that A complement means that all regions within the universal set without A So what this means is that we are going to shade the entire region within the universal set without touching the set A. When we do this, we will get something like this. So as you can see from the screen, the region shaded with the blue color is A complement. As you can see, we've left the region A and we've shaded the entire area or the entire region within the universal set. Let's look at our next example. Now let's look at the region A only. Let's first show our Venn diagram of two intersecting sets, set A and set B. It is very important for us to note that A only is not the same as A. This region is A, but it is not the same as A only. The reason is that some aspect of it is in B. A only means A without B, pure A. Now, this is the region that represents A only or pure A. This region does not have B inside, so that's why it is pure A. So let's shade that. Now, because A only means A without B, what this means is that we can represent it by the notation A intersection B complement. B complement means without B. So A intersection B complement means A without B. It's as simple as that. Let's look at our next example. For this example, we'll be shading the region set B. First, we'll show our Venn diagram of two intersecting sets, set A and set B. Shading set B is very easy, so let's quickly do this. This is the region that shows set B. Let's look at the next example. Let's look at set B complement. As usual, we'll first show our Venn diagram of two intersecting sets. As we already know, B complement is the region inside the universal set other than the set B. So as usual, we'll be shading the entire region within the universal set, but we will not shade the region B. This will be our answer. The area shaded blue is B complement. As you can see, it is without the set B. Let's look at the next example. For this example, we'll be looking at B only. As we've already established in A only, B only also means that B without A. So this can also be represented by the notation A complement intersection B. A complement means without A. So A complement intersection B means without A intersection B, which means pure B or only B. Let's now show our Venn diagram of two intersecting sets. So this is the region that shows B only or B without A. Let's look at our next example. Let's look at the region A intersection B. First, we'll show our Venn diagram of two intersecting sets. Let's note that A intersection B means the point or the region where A and B meet. Let's also note that the members in this region have characteristics that are in A and also in B. So they have mixture of characteristics of A and B. Clearly, this is the region where the set A and the set B intersect. Let's look at our next example. Next, let's look at A intersection B into bracket complement. So here we are looking for the complement of the entire item in the bracket, which is A intersection B. First, we will show our Venn diagram of two intersecting sets. Let's note that for us to be able to find the region A intersection B complement, it is very important for us to first know A intersection B. This region is our A intersection B. But of course, this region is not the same as A intersection B complement. For us to find the complement of this region, we will need to shade the entire region under the universal set without touching the region painted red, which is A intersection B. So let's quickly do that. So this area painted blue is the complement of the area painted red. Therefore, the blue region is A intersection B into bracket complement. Let's look at the next example. Next, let's look at A union B. First, we'll show our Venn diagram of two intersecting sets. Now, let's look at union. The word union simply means two or more things being brought together to unite. So, the union of set A and set B, or set A union B, simply means set A being joined together with set B. First, this is our set A, and this is our region B. When region A and region B are joined together, you get the blue shaded region shown on your screen. So the blue region is the area that represents A union B. Let's look at the next example. Now let's shade the region A union B into bracket complement. First, we have our Venn diagram of two intersecting sets. Let's note that before we can find the region A union B complement, it is very important for us to first know A union B. This is our A union B. Now that we've been able to recognize our region A union B, we can find A union B complement. Let's note that A union B complement is the region within the universal set other than A union B. So we'll be shading the region in the universal set, but we will not shade A union B. So the area shaded blue is our A union B complement. Therefore, A union B complement is the area within the universal set outside A union B, as shown on the screen. Let's move to the next example. For this example, we'll be looking at the region A intersection B complement all into bracket union A complement intersection B also into bracket. So as usual, let's first show our Venn diagram of two intersecting sets. To shade the above region, A intersection B complement into bracket union bracket A complement intersection B, we would have to just do it step by step. First, we shade the region A intersection B complement. I believe you remember A intersection B complement. A intersection B complement simply means only A. That is A without B. The B complement means without B. So it means only A. So let's quickly shade that. So this is A intersection B complement, which is the same as only A. Now let's shade A complement intersection B. I believe you remember this also. A complement means without A. So this also means without A, only B. So A complement intersection B simply means only B. So let's shade only B. So this is the region A complement intersection B, which means that only B without A. At this point, we'll be doing the union of the two. Remember, we are looking at the region into bracket A intersection B complement bracket union of A complement intersection B bracket closed. So what it means is that we have to merge only A to only B. We have to merge them together to get the union. So when we do the merging, we'll get something like this. So the blue shaded region is the answer to this problem. That is the region A intersection B complement or union A complement intersection B. Now let's look at the De Morgan rule or De Morgan laws. We will be looking at two of them. Let's look at the first law. For the first law, if you have the notation A union B all into bracket complement and you want to remove the bracket, write A complement, then change the union sign to intersection sign, then you write B complement. It's as simple as that. So that's the first law of De Morgan laws. Let's look at the second law. For the second law, if you have A intersect B all into bracket complement and you want to remove the bracket, this is what you must do. First, write your A with your complement sign, then change the intersection sign to union sign and write your B with your complement sign. So you get A complement union B complement. So these are the two De Morgan laws, and I need you to remember these laws. Now let's shade the region A complement union B complement. From the De Morgan law, we know that A complement union B complement is the same as A intersection B bracket complement. Now it is very easy for us to shade the region A intersection B into bracket complement. So let's quickly do that. So that is A intersection B into bracket complement. And we did this by shading all the areas under the universal set other than A intersection B. Let's look at another example. Now let's shade the region A complement intersection B complement. From the De Morgan law, A complement intersection B complement is equals to into bracket A union B bracket close complement. It's very easy if you have to shade A union B into bracket complement. So that's what we will shade. And it's the same as A complement intersection B complement. So that is the answer. Now let's do something else. Well, friends, at this point we will be bringing set and set operations part 4 to an end. In our next meeting, we'll be looking at the part 5 of this topic. And in part 5, we will again learn to describe and identify the various regions of the Venn diagram, but this time around we would focus on 3 intersecting sets. Thanks very much for staying with us, and please subscribe for this channel if you have already not done that. We need your subscription for the continuation of this program. Also, once you subscribe and we make or come up with new videos, we will get you alerted. Thank you. Stay safe until we meet again in the next video.